Hey, what's happening, guys? We have talked about diodes in the past. We've talked about regular silicon switching diodes and Schottky diodes a little bit. We'll get more into Schottkys later. But today I thought we would talk about this guy, the Zener or Zener, depending on where you're from, diode. And this is an interesting little guy because it has a forward and a backwards behavior. Now, just like any diode, the cathode is marked with that little black stripe. But what makes this interesting is what happens when we reverse bias it. So let's talk about that for a second. Okay, here's a simple little graph. We have voltage in the horizontal axis and current in the vertical axis. So from our 0 point, moving to the right, we have voltage forward, and moving up, we have current forward. Moving to the left, we have voltage reversed, and moving down, we have current reversed. Now, if we have a regular diode, nothing happens in this entire region here until we reach the junction voltage, 0.6 or 0.7 volts, and then our diode starts to conduct. But Zener diodes are just a little bit different. Well, they're actually more than a little bit different. They are incredibly different. So here is our forward voltage curve. And it looks like a regular diode. When we reach this point right here, between 0.3 to 0.7 volts, the diode begins to conduct. But something very interesting happens when we move this way. And this area here is called the Zener breakdown area or region. And when we reverse bias that Zener diode, when we reach this point, whatever this point may be, the diode conducts in reverse. And that can be very useful for voltage regulators, clamping circuits, voltage sources, just a myriad of reasons why this can be so useful. Because remember, our regular diode does nothing in this region, and it only conducts forward. But if we reverse bias our Zener diode, well, we have this whole new area here that we can play with. And now we have a controllable voltage here, because that voltage, whatever it may be, will not pass this point. And that's why the Zener can be used as a clamp or as a crude voltage regulator. So we'll take a look at that in a future video, but there's something else I want to talk about today. There's a regular diode, small signal diode, and we know that it's going to conduct somewhere in this area, depending on the current. And we also know that our Zener, forward biased, will conduct in this area. But we don't know, unless you have a brand new package of them and you can read off the package, what that reverse Zener diode voltage is going to be. Because it's not marked anywhere on here. No, sir. How can we find it? I'm going to show you. And it's not hard at all. It's very simple. All we need is a resistor, a power source, and our Zener, which we're going to put in here reverse biased. So let's set up our power source first. All right, we're going to use a 9 volt from my power supply. And since the meter on my power supply is not particularly accurate, I'm just going to calibrate it using the meter here. Come on. Give me 9 volts. Okay, close enough. So, what we're going to do is we're going to, let me zoom out here a little bit. That's in. There we go. That's out. So I'm going to hook the power supply up to our little circuit here. If I can get my fingers to work. Plastic, rubbery, slippery. Okay. So we're now reverse biasing that Zener at 9 volts. And we know that when we reach that mystery voltage, it won't conduct any further. So if we put our probe on here, we get 3.99, let's call it 4 volts. That is a 4 volt Zener. And that simple little circuit, which I've drawn here, is all you need to find out the Zener voltage of your mystery Zener diode. And that's all for today, because it's Sunday and it's Super Bowl Sunday. So if you guys enjoyed this short little video, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. A big thanks to all my patrons. Big thanks to you guys. That's it. I'm out. Peace.